The general process that we'll employ to solve a linear programming problem graphically will be to first graph the constraints. We'll then find all the corners. Once the corners are found, we can evaluate the objective function on the corner points. Once we've evaluated all the corner points, we can interpret what the optimal corner is. And this will depend on if the objective function is asking to find a maximum or to find a minimum. Because we'll frequently be dealing with word problems, we might have an additional step 0, which is to interpret the constraints and objective function from the given word problem. We also have a step 2.5 for linear programming problems with unbounded feasible regions. These extra steps will be covered in the next video. Let's work on the following linear program. A student field trip is being planned. The 2 available vans can fit a total of 12 people. To receive permission for the trip, there must be at least 2 adults. To receive school funding, the number of students cannot be less than half the number of adults. If it costs $10 for adults and $5 for students, what's the cheapest trip? If adults can carry 4 snacks and students can carry 1, what's the largest number of snacks that can be brought? First, let's think of what our variables will be. The things that are changing are the number of adults on the trip and the number of students on the trip. Because we want to graph our constraints, let's use variables x and y. We'll have adults be x, and we'll have number of students be y. Let's work through our problem and identify our constraints. We're told that the 2 available vans can fit a total of 12 people. This can translate to the number of people on the trip, x plus y, is certainly not more than 12. We're also told that to receive permission for the trip, there must be at least 2 adults. So we know that x is at least greater than equal to 2. You also see that to receive school funding, the number of students cannot be less than half the number of adults. So the number of students, y, cannot be less than, meaning greater than or equal to, 1/2 the number of adults. Giving us the equation, y is greater than or equal to 1/2 x. Here we actually have 2 objective functions, and that's okay, we'll just do one at a time. The first tells us that is about cost, and we want to find the cheapest trip available. For each adult, it'll cost $10, and for each student, it will cost $5. And that's something that we want to minimize. We also see that we want to find the largest number of snacks that can be brought, so maximize, and we're told that adults can carry 4 snacks and that students can carry 1. This gives us the objective function 4x plus 1y, and we want to maximize it. To focus on the new material for this section, I'll just quickly go ahead and graph these and find the corners. Our feasible region is bounded in the shape of a triangle. We have 3 corners. Our first corner I found to be 2, 10. Our second corner to be 8, 4. And our third corner to be 2, 1. Now we want to evaluate each corner for our first objective function, 10x plus 5y. We get 10 times 2 plus 5 times 10 for a total of 70. We get 120 for our second corner and 25 for our third corner. Because we're trying to minimize for this one, our optimal solution is going to be 25, and our optimal value for our first objective function will be the point 2, 1. We'll interpret what this means in a moment. To evaluate our second objective function, we can get that our first corner evaluates to be 4 times 2 plus 1 times 10, which is 18. Our second corner being 4 times 8 plus 1 times 4, which is 36. And our third corner evaluated to be 4 times 2 plus 1 times 1, which is 9. Because we were trying to maximize the second objective function, our optimal value is 36, and our optimal solution is 8, 4. To interpret our final answer, we would say that to minimize cost, or that the cheapest field trip would involve 2 adults and 1 student. To maximize number of snacks that can be brought, we'd want to bring 8 adults and 4 students. Depending on the problem, they might also want to know what the actual optimal value was. So I'll just jot those down as well.